Right, about me. I am Arnav. I have been with ThoughtWorks for a little over 8 years now, and I work as an infrastructure consultant. And hopefully you should be able to see my screen now, correct? Okay. So a brief recap of what we've seen so far. We had Ashi and Pooja walk us through what is authentication and authorization. And then Nidhi gave us an overview of how Rego works, what is a policy file, what is the data, what is the input, and we had a use case of Netflix where there's a customer, there's support, there are two personas, and then there are certain rules that have to be followed based on what they can access and what they cannot access. So to quickly reiterate our scenarios, a person who is a user should be able to view only their own accounts. A support member can view a user's account only if they're assigned an open ticket to this account, and the user should not be able to access the details of a support person. So you've seen, given a certain set of data and a Rego file, which lists out all of these policies, how would the interaction with OPA look like? Now we'll see how we implement this in the application, in a web application. The application you're going to see is only deals with the web portal side of things. Sorry. Yes. So it only deals with the web portal side of things. And we already have all the data here. The authorization layer sits somewhere over here. And we'll see how this works. So this is what the application looks like. On the left side, I'm going to log in with the account of a user. And on the right side, I'm going to log in with the account of a support person. So one, I hope this works. So one, and there. This is the portal of what the support of a customer would look like. They have notifications, they have the tickets that they've raised, and the payments that they've paid for their account, and their account ID and stuff. And I will quickly log into the support person's account. There you go. So this is their page. They see all the tickets, and these are the tickets that they have. And we can see that this user only has one ticket assigned to them, which is the last one. The others are not. So first things first, we want to make sure that the customer cannot access the users, the support page. And given the beautiful application that is, I do not have a navigation bar, so I will have to go by the address bar. And if I go to the tickets page, I get a blank page, which basically means I cannot access it. My 403 page does not work properly, but if I show you by inspect element, I will get an error response saying that it doesn't work. Let me try this again. And there you go. Basically, the request failed successfully, which is what we wanted. Brilliant. We now go to the next side of this application, where we want to make sure that the support person cannot access an account for which they do not have an open ticket. Right now, because these two tickets are the same account, and they have an open ticket here, so they can access the account, which is user 2's account. Just fair, just brilliant. Let's try to access this account, which is the account for user 1. And again, blank page 403, they cannot access it. All of this is well and good. How does it work? So you would have seen on the Q&A and on the chat that there was a question around how can you run OPA? Does it run as a server? Does it run as a library? How does it run? So there are 3 ways, if I get it right. There are 3 ways to run OPA. One is as a standalone server, as a standalone service rather. One as a Golang library and integrated into a Golang application. The third is as a Node.js library, and the Rego file gets compiled into a WebAssembly module, and then it gets used in the Node.js service. I have not used a Node.js service, but I can show you how this works in a Golang application. So A little bit about the application. There's a front end, there's a back end. The back end is in Golang, the front end is in Vue.js. The back end uses a RESTful web service framework to build RESTful web services for lack. That's where we are. It consists of a routing mechanism which knows how to point which requests for a URL to a controller, which comes from the model view controller model of viewer. And there's a feature in this framework that you can have filters. What a filter does is it can pre-process the request that comes in before actually forwarding it to the controller for actual processing. We have an authentication filter here, and we have various authorization filters over here. Oh yeah. So the auth filter simply makes sure that the person that you are logged in or not, which is basically what Pooja and Ashi had told earlier, that you try to make sure that you're authenticated before you're authorized. Now, if I go into my authorization filter, I have two filters to basically handle things easily. One is an account authorization filter, which checks whether, given me as a user, if I'm trying to access an account, am I allowed to access that account or not? The second is a support filter, which checks whether if I am trying to access the support page, which is the /tickets page, do I have permissions to access the tickets page or not? We'll go to the authorization filter. This is where we are. The filters internally call the same function, which is a wrapper around the OPA Golang library. What it does is it takes two parameters to build what is known as a prepared query. The two parameters are one, the policy itself. The second is data for reference data for running the policy against. Now, the policy itself goes in as a string value, which means that you can load it from wherever you please. You can load it from a database column. You can read files and load that, and then load the rules into the policy into this string and then use it. The data comes in as a map, and the data can also come from anywhere. I am using flat JSON structures to make things easier for me. But again, your data can also reside in a database and then loaded into appropriate classes and then moved into your application as and when required. Once we have this prepared query, the query then takes in an input, which again is a map of strings, and then we ask the OPA library to evaluate this full query, where we have the policies, we have the data, and we have the input, and then we get a response, and then we can use the result and then take decisions on it. So I will quickly show you my data. My data has three primary elements. First is users. This has user ID, name, password, and the role of the user. So I have two users and two who are customers and two users who are support users. Then I have account details here, where I have an account ID and a user ID, and then I have tickets. So this tells me that there is a ticket which was raised for a given account, and it is now assigned to someone. And then there is some text around what does the ticket say. So this is the basic data on which my policy checker runs. I will now show you my Rego file. My Rego file is fairly simple. It exports two rules by default, which is the view account. Well, they're called expressions. So view account expression and support expression. So what happens here? Let's take the example of support, because I think that'd be quicker to explain. So when someone makes a call to tickets, I've made sure that authorization has gone through. Then I forward my entire request data into my support authorization filter. I go into the filter. From the request, I take out data that I need. First, I figure out what is the query that I'm trying to run. The query here corresponds to the expression that I want. If I wanted to look for to check whether the user is a customer or not, I would have passed in customer. But because I need support, so I'm going to see whether the pass in support as a query term. Then I use the session and my data store to figure out what is the user and what are the details. I get the user ID here. And this gets passed on to my function that to my wrapper function over OPA. Now, if we take the example here, I am logged in as user 1 and I want to access the support page. So let me actually split this open to the right, it might be easier this way. So if we'll open up the details for user 1, what would happen here is in the input, I would get the user ID of user 1, and I would run it against this rule. So this would check whether from the data of users, figure out what's the user, we've gotten this user, and then check if the role is support or not. It's not support, it's customer, so we get a 403. It's a similar case for the account authorization header, account authorization rule. The only difference here is in the input, along with user ID, we send in an account ID. And the rule gets evaluated as first check whether the user who's coming in is the owner of the account or not. And how does that work? We figure out we get the user ID, we get the account ID. We check whether the user is a customer or not by checking whether their role is that of a customer or not. And then we fetch, and from the accounts data, we try to find the account which we are requesting by looking up with account ID. And then we check whether the user ID of this account matches the user ID who's trying to process it. So that tells you whether this user is an owner of the account or not. And if they're not, then we go to the next phase where we check whether the user is a support user. If yes, then we again figure out which account this is for. And with this account ID, we figure out all the tickets that are logged into our system. The tickets are over here. Let's say I open the third ticket. And from the ticket, I see if the ID of the signee is the same as the user who is trying to access. If that doesn't match, we deny the request and we get a 403 response. So this is one way to do it. We'll go back to my slides. Yes, so this is one way to do it because I've done this way because it was the easiest for me. There were a couple of questions regarding the usage of OPA as a service, right? I can give you a real world example of how we are using it in our on a project. We have a team who manage permissions and who have built up a service that does permissions. But all that service is an interface to create the reference data that we were talking about earlier. It doesn't actually have HTTP endpoints to enable OPA and Rego evaluations. What we have instead, we have is a Golang library, which at the end of the day is a wrapper over the OPL Golang SDK. And just like I've used a filter here, we have various filter methods where we pass in parameters. Check, so we would do things like this is the customer. So does a customer have read permissions on, say, notifications for Animations account, for example. And all of this data is stored in a Postgres database. The policies reside in a different table. The data resides in a different table. The authentication library first makes a call to the database and then fetches all the data that is necessary to run the OPA query, the Rego query. And that is how authentication works on our end. And that is all I have for you by means of a demo for using OPA in an application. I will now hand over to Sparsh. And if you have any questions, keep them flowing in the Q&A section.
Okay, hello everyone. I'm Sparsh. I'll take you through the demo on Kubernetes. So yes, all the infra people, all the DevOps champions, we all have problem with people running pods and people running pods with insecure policies and everything. So we want some kind of policy mechanism to work with the Kubernetes where we say, okay, you can do this and you cannot do this. And yes, OPS solves that for us. We have some Kubernetes native solution, but the whole value of OPA is to run a single system that can do everything for you. So you can use OPA with your Kubernetes, you can use OPA with Istio, your networking solutions, your Linux permissions, your cloud permissions, and everything. So in the demo, I'll have two things for you. First is when we do a deployment via YAML or a JSON file, how can we do that? So in most of the production use cases, a lot of time we create JSON files, we create YAML files, and then we uh, deploy them via CI/CD system. And that would be Jenkins doing it or GoCD doing it, and it would be running your kubectl commands to deploy these pods or deployments. And then we'll discuss another system. What if we do not want to check in our CI/CD, and what if we want something to sit on our cluster and just monitor what's happening in the cluster? So that is Gatekeeper, and we'll talk about Gatekeeper briefly. So starting with the first very simple use case. So this is my Rego file, and I'm just saying that I want to run the pod as non-root, and non-root should not be true. This is a not command. And the another condition is that my images should not have a latest tag, or they should not be naked images. They should contain a tag that could be based on your GitOps setup or any other setup or pipeline setup with whatever you have done. But the two conditions we are checking here is that the image should not contain latest, and it should not contain run as non-root to be true. Now this is my pod JSON, and I have set my run as non-root as false, but the image is not latest. So what if I run a policy here? I'll just switch. So I'll go to the system. I'll say OPA simple, and then a file list. So I have my Rego file and I have my pod file, and I'll do a OPA eval, and I tell it which test to do, which rule to run, and it says container must not run as root. Now, OPA CLI provides you different kinds of outputs, sorry, bindings, and it can give you the binding. You can do a pretty output, and it will give you a box, yeah, output in the box. Now, let's say we do this to true. We say, okay, we are not running as non-root. And then what it will give? It will give me an undefined error. And if we do a JSON output, it will give me an empty JSON. So the end goal should be to get an empty JSON. Let's try this with latest as well. And if I do eval and it says, okay, container uses image that are tag latest or images with no tags, and simply you could check that your JSON should be empty, and you could evaluate it with JSON, JQ later. So this is one way to do it in CLI, or this is direct integration with your CI/CD system. Now let's talk about Gatekeeper. Now, when we talk about API server, when we talk about Kubernetes, the controller of Kubernetes is our API server, right? So our API server, whenever we do something, right, whenever we run a command, it does three things to that request. It will first authenticate it, then it will authorize it. So authorization could be simple RBAC authorization, what a user can do, if the user is allowed to create pods or not. And then we can have admission control. And admission control is something what happens when you create, update, or delete something. So that is what admission control. So admission control is like, should I admit this request? Does this follows all the different authorization or rules, or does this follow all the resource policies, different policies, right? You can have different policies. You can have our resource policies, quotas, ephemeral quotas, volume quotas. So does this allow all that? So what what Kubernetes does is it allows webhooks in itself. So you can write your own admission control and say, okay, Kubernetes, I'll check the admission control for this cluster. So we can have two kind of integrations with OPA with Kubernetes. One is let's configure API server to directly talk with OPA. So in this case, you will add your OPA Rego policies and it as config map, and then it will read. And whenever there is a request to API server, it will first ask OPA, okay, should we admit this request or should we not? Uh, but then what Gatekeeper does is is something like that is built on top of OPA, right? So you have a open source Kubernetes, but then you have OpenShift that can do a lot of different things on top of open source Kubernetes. This is the same with OPA and Gatekeeper. Now, Gatekeeper, the advantage is it can talk with your OSG webhook and it can also talk with your admission controller. So it can do both things. It can also check if a user is allowed to do that or not, and it can also check if the resource policies are met or not, right? So for example, if I am allowed to create a pod here as well first, and then if my pod fulfills all the resource requirements, if the CPU and memory requested is below what is available, so these kind of admission controller and OSG webhook you can do with Gatekeeper. Now the extra things that you get with Gatekeeper is the audit results. Now what happens if there is an already created infrastructure, you are already running an application on Kubernetes and your pods are already created? What do you do then? So this is admission control, right? Whenever you do something, whenever you update or create. But what about when things are already created? So Gatekeeper provides you auditing where it will continuously check if something is not violating the rule, and it will have a watch, and it will if there is something, and it will raise the violation. And how does Gatekeeper is implemented in uh, Kubernetes? So and so we'll talk about the implementation in a time, and let's start with the policy. Like, what are the advantages we get over OPA? So first, we get an extensible parameterized policy library. So what Gatekeeper has done is it has created a library of policies for Kubernetes. So instead of writing your own Rego files, your own policies, you can just use them and like a plug and play policy library. So you can just create them as in your cluster, and then they could be implemented. And how does it do? So Gatekeeper uses the concept of CRDs, custom resource definitions. So what it does is you can extend the policy library, you can have the template, and you can say this is the template of this policy. So you can have a Rego policy and you can create a template out of it, and first create the CRT of the template. And then on the template, you can instantiate that template with a constraint. So we have two things. First is the constraint template, and second is the constraint. So I'll show you an example on how do we do it. And then there is audit functionality, and then it can, someone was asking if you can get metrics on how much policies are enforced or all these things. So metrics, Gatekeeper produces metrics, how many policies it enforced, or how much violations are there, and all these things. You have that advantage over plain OPA. In plain OPA, you will have to write your own exporter or something. So moving on to demo, I'll close this. So this is my constraint template, and this is my constraint. I'll open both of them side by side. Okay. So my constraint template says it has a name, and it has a template API version from Gatekeeper, and it says that I'll accept a CRD which will have the kind K8s required labels, and then it will have a policy. It will have a Rego policy which says check the label of the pod, check the label that is required, and if the label is missing, you should say, okay, you must provide labels, otherwise this would not be deployed, right? So pretty simple policy template where it says I need these labels. And how does it compare? It gets your input review object from the pod YAML, and it gets input parameters label from your CRD template. You say properties labels. So you say I need these the schema is I need properties with name label. Now this is the template and of the CRD. Now this is the actual CRD, and it says the kind is required labels. The kind we mentioned here, we should match. It must then have a name. And we say, okay, apply this policy on the object kind namespace. So namespace is kind of an object in Kubernetes, right? And it says the label gatekeeper should be present. Now, what is the advantage of having templates and constraints different? So let's say this is my template where it says, okay, the label should be there, but I can have multiple constraints. I could say, I'll just copy this and I'll say, I want this to be on pods and I want it to have environment label. I want it to have team owner label, right? So with same policy template, you have now two constraints. One is working on namespace, one is working on pod. You can have different names for it, right? So this is the advantage of template. You can have a template, you can extend it to on whatever conditions you want. Now I'll show you the demo. Right, so I have a cluster. So I have some shortcuts installed. This is just nothing kubectl get pods. So I have a cluster. It is running Gatekeeper control manager. It is also running an audit pod. And so we'll apply the, I'll go to Gatekeeper and we'll apply the template first. It says constant templates created. Let's create the constraint then. Right, so my constraint is also created. So if I do kubectl get, so my constraint is of kind this, right? K8s required label. So I'll do K8s required labels. It says namespace must have a gatekeeper label. So, and I can also describe this. And it says there are total violations, namespace, kube system does not have label. So this is your auditor working, right? So auditor already ran, it's checked, okay, you have 4 namespaces, but then they do not have the label. Now let's try to create a namespace. So I have a namespace YAML. It's just create a simple namespace. Let's try to run it. I hope this is better for you, kubectl. And when I try to run it, it says, okay, error from the server, you must provide label gatekeeper. So it does not allow me to create namespace. And this is what admission controller is. Now I'll, oh, sorry. Now I'll remove these label. I'll add the label. And now if I do my ThoughtWorks namespace is created. Pretty simple use case, right? But then we can extend it. So you get the idea. You can extend it to different places you want. You can check if the pods are not running with root user, uh, or they are not exposing ports that are not required. These kind of things, policies, whatever your production or requirement feel, you could do that. I had planned for this session, but then the time is pretty less. So we can extend this with Kubernetes as well, right? So you assume you have a Kubernetes code, you have a Terraform code to deploy cluster. So right now I am doing this on K3D. But then if you have a Terraform code, you can extend this to Terraform as well. Pretty simple. You have a Rego file that does something. Let's assume this does something. This checks my Kubernetes code somehow. And then how do I do it? So you can do Kubernetes output, plan output as JSON, and then again use a CLI to check this. Now, one question here that if you say, okay, I have written JSON, nobody writes JSON, everybody uses YAML. Okay, yes, I agree. We use YAML. So you would just simply do a kubectl apply -- dry run and output JSON. So you can get JSON like this. So yes, that's it from my session. Pretty simple examples, both of them where we could use in production directly. Yes. Thank you, everyone. Bye.
Great.